Okay, reflections practice homework. For each graph, we're just going to call these graphs like the general f of x function. We're going to sketch its reflection in the x-axis. So I'm just going to choose a couple points. So any point on the x-axis is going to stay there, so that's fine. This point is really nice because it's right on 1, 4. So instead of going up 4, it's going to go 1, 2, 3, 4, down 4. Okay, and this is 5, 4. So instead of being up 4, again, it's going to be down 4. Okay, so then this is negative f of x. Okay, I'm going to do all of A. So we're also going to state the domain and the range. So for this one, domain doesn't change. It's still XER because we haven't affected the x's. Now, the range we affected, we reflected it, right? So instead of it being y is greater than 0, now it's going to be y is less than or equal to 0. Okay, and now we're going to sketch the reflection in the y-axis. So this 3, 0 will go to negative 3, 0. This 1, negative 4 is going to go to negative 1, 4. This 5, negative 4 is going to go negative 5, 4. That's a reflection. That's this reflection in the x-axis. I mean, if you did the reflection off of f of x, it'd be the exact same thing, just from the original here. So same point here, 5, 4, negative 5, 4. Okay, so this is reflected in the x-axis, or this is, or sorry, y-axis, and this is reflected in the y-axis. Maybe we'll just do it off the original. I think that's good. So if we do it off the original, it's this one. Okay, for B, we have something that looks like a root function. Okay, so if we reflect it in the x-axis, this point is negative 2, 3. So now we're going to go negative 2, negative 3. Okay, the y-intercept is just above 7, so the y-intercept is going to be just below 7. And I'm just looking for one more good point. I'm going to go with this here, 2, 9. So I'm going to go with 2, negative 9. Okay, so if this is f of x here, this is going to be negative f of x. And the domain's not going to change. X is going to be greater than or equal to negative 2 here, right? However, the y is going to change because instead of going up forever, now we're going to go down forever. So our reference point for the y is this negative 3. So y is less than or equal to negative 3. And if we were to take this function and reflect it in the y-axis, again, anything on the y-axis is going to be the same. Now, instead of going negative 2, 3, we're going to go 2, 3. Starts us here. And then instead of 2, 9, we're going to go negative 2, 9. So this is going to be f at negative x. Okay, and last one. If this is f at x, I'm going to reflect this in the x-axis. So at negative 2, instead of going up 3, we're going to go down 3. Instead of going up 3, we're going to go down 3 here. Instead of going up 1, we're going to go down 1. Up 1, we're going to go down 1. And up 2, we're going to go down 2. So this is negative f at x. So for the domain and range of that one, we're just going to look at what x is between and what y is between. I mean, we didn't do the domain and range for the original, so we have nothing to compare it to. However, only the x would actually change. So now we're going to go negative 2 to 6 is the x's. So x is between negative 2 and 6. And the y is going to be between negative 3 and 3. Okay, and the last part, we're going to take this function and we're going to reflect it in the y-axis this time. So instead of being -2 and 3, we're going to go 2 and 3. Instead of going 2 and 3, we're going to go -2 and 3. So this line actually stays the same, but it is reflected. Instead of doing 3, 1, we're going to go -3, 1. Instead of going 5, 1, we're going to go -5, 1. And instead of going 6, 2, we're going to go -6, 2. So this function here is going to be f at -x. Okay, correction here. -3, sorry, to 1. I was looking at the original. So this goes to 1. Okay, for each function, determine the equation under the indicated reflection. Okay, so for A, we have an equation f at x equals 2x minus 7. Now, we want to determine the equation of G where there is a reflection in the x-axis, right? So what happens here is we reflect f at x like this. So we're going to go negative and then the entire function, 2x minus 7. Distribute that in, -2x plus 7. So if you wanted to algebraically find the equation for the reflection in the x-axis, this is how you would do it. Okay, for B, we have f at x equals 3 bracket x minus 4 squared plus 5. Again, we want to find the equation where we reflect f at x in the x-axis. So we're going to put a negative sign in front of the entire equation and then write it out. So this here is actually one term because they're multiplied. So when we distribute this in and we find g at x, we're going to go -3 x minus 4 squared, and then this is just going to distribute onto the 5 to create -5. Okay. C, f at x equals root 2x minus 1. This time we're going to find the equation where there's a reflection in the y-axis. So every time we see an x, we're going to put in the bracket -x. So f at -x equals root 2 -x minus 1. So if we actually multiply these by one another, we would get -2x, and then the -1 would just come down, and that would be our g at x. Okay, so d is going to be this function, and we're going to reflect it in the x-axis. So for d, I'm going to do down here, f at x equals, so what we're going to do is we're going to put the entire function in the bracket, 2 over x plus 3 minus 2. So when we distribute this negative sign in, we distribute it to each term. So this right here is an entire term, and then the next one. So I get -2 over x plus 3 plus 2. And that's g at x. Okay, E, we're going to take this function and we're going to reflect it in both the x and the y-axis. So when we have f at x equals -root 3x plus 4 minus 1, I'm going to do this in 2 steps. First, I'm going to reflect the actual function. So I'm going to reflect the entire thing. -root 3x plus 4 minus 1. Okay, so let's put it into here. And remember, this entire thing is a term, and we're going to put it into there. So -f at x is going to look like this. Root 3x plus 4, right, because that goes to positive, and then plus 1. Now what I'm going to do is I'm going to take that -f at x, and I'm going to negate every single x value. So 3, negative x, plus 4, plus 1. Okay, so I'm going to have negative f at negative x, which is also known now as g at x. And I have, if we multiply that, it's negative 3x plus 4, and then plus 1 outside of the brackets. Okay, last one, f. I'm going to give myself more room. Okay, so f is going to be here. We're going to do the double reflection. So f at x equals 2x cubed minus 6x squared plus 7x minus 9. So first, let's actually reflect the entire function by putting a negative sign in front and then the entire function in brackets. Okay, so this negative sign distributes and we negate every single term in the bracket. So 2 turns to negative 2, negative 6 turns to 6, 7x turns to negative 7x, negative 9 turns to 9. Now what we're going to do is we're going to negate every single x value. So negative 2 and then negative x cubed in brackets plus 6 and then negative x squared. Negative x in brackets, negative 7, negative x, and then plus 9. So to simplify this, if we were to cube negative x, it would still be negative. So we would still have x cubed, but this negative we can collect out front. So it would be positive x cubed. Now, if we were to square a negative, it would just be x squared. So it wouldn't do anything, it'd just be positive. So it would just be 6x squared. Okay, negative 7 times x is, or negative x is plus 7x, and then plus 9 we just bring down. Okay, for each graph, describe the reflection that transforms the original function f at x onto g at x. Okay, so I'm assuming the original function is the solid line. So this to me is a reflection in the x-axis. Okay, so it went from, for example, 2 to negative 2. And it went from 6 to negative 6, right? So I'm going to say reflection in the x-axis. Yeah, and then that's it. Okay, so for B, we had the original, which is the black, okay? And here's the vertical and horizontal asymptotes. Again, those vertical and horizontal asymptotes are not going to change with a reflection. So if this part reflected onto this part, we could say that it's a reflection in the y-axis. And this would reflect onto this. Okay, last two. C is a little bit more self-explanatory. Of course, this is a reflection. And like the 3 would reflect down onto the negative 3. Let's go, nice number. 8 would reflect down onto negative 8. Okay, so this is a reflection in the x-axis. Okay, and I think that this is a double reflection because negative 6 here would have to reflect to positive 6. And then it would have to reflect over, so it would have to reflect over the x-axis and then the y-axis. So reflection in the x-axis and y-axis.